So in today's class, we are going to discuss the week 2 practice assignment. First, let me give you a brief introduction about the concepts, and then we'll start answering the practice questions. Yeah, Sachindra?
Hi, ma'am. Good evening, ma'am. Hello?
Yeah, tell me.
Good evening, ma'am.
Tell me, ma'am.
Ma'am, the thing is, in my course, that C programming is not activated, ma'am. Whenever, however, I have applied it, but it is saying you are not registered for this course, and it is opening in data science.
Contact the operational team, ma'am.
Sorry?
Yeah, support team, you contact the support team.
Can you share phone number?
Support, you'll have a mail, no? Support team.
Mail, they are not responding. It always in five times I have shared, and it is already 5 days over now.
Yeah,
They are not
yeah.
responding.
You
Even
type
I have
your mail ID.
share this link.
You type your mail ID and your ID in the chat so that I will inform them.
So, ma'am, today we will discuss the week 2 practice assignment.
Yes, week 2
Okay,
practice
ma'am.
assignments with the concepts.
Okay.
And ma'am, week one graded assignment, problem number 10. I think that this is not clear now. This
Yeah,
statement is having some
it-
ambiguity.
yeah, we'll look into it. Let me see it. First, let me discuss this week 2, and then we'll come back to the issue. What issue we have, I will verify that.
Whether this week one has been discussed or what, ma'am?
Week 1 already discussed in the last week, no?
Okay, I was not aware about it.
Yeah, recorded video will be there in the YouTube channel of this course. You can follow that. Type your roll number and in the chat box,
Yes, ma'am.
roll number and your mail ID. And also switch off your mic, ma. There is some lot of sound coming. Okay. Is my screen visible?
Yes, ma'am.
Okay. So mainly the week 2 will cover the number system. So in general, the computer can understand only the binary number system, that is in ones and zeros. Okay, binary number system which is in ones and zeros only. So, but our daily notation, we follow the decimal number system. Okay, so even though there are so many number systems, generally the C programming will support 4 types of number systems: binary, octal, hexadecimal, and decimal. Okay, so we will see how these number systems are represented and inside the computer, and also how to convert one number system into another number system. We'll see the method. Okay. Then how you join this session, ma? Because you are saying you are not added to the C program, so you might have you not got the calendar also, no?
I am added to the C program, but that C programming laboratory is not opening.
C program
Lab.
lab.
Yes, ma'am.
There is a separate registration for lab and theory.
Yeah, so ma'am, I have
Have
paid
you-
for both. I have paid for both, ma'am. And
Okay.
in my course, in my current course, it is showing three subjects. No, one is C subject, then C lab, and then one is ESTC lab, electronics lab.
Okay.
So only C programming is working. Other two are not working.
C programming lab theory is working.
Theory is working, ma'am.
Okay. Lab is not working.
Yes, ma'am.
Okay. I'll inform the team.
Okay, thank you.
So the binary number system uses the digits 0 and 1. Okay. So each digit we call it as a bit 0 and bit 1. Okay. Anything, any number, if you want to represent, you have to represent in the form of ones and zeros. Okay. So first we'll see how the binary number system will be formed, and you should be familiar with 0 to up to 15. Okay. How to write the binary numbers from 0 to 15. You must and should familiar with that. Okay. So generally, tell me the process, how you will write the decimal number system. So there are 10 digits. Deci means 10. There are 10 digits in the decimal number system. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 10 digits. So after 9, what we are doing? After 9, what we are doing? 10. That means you are placing 1 in the 10th place and 0 in the unit place. Okay. So that means what is the 10th position for all these numbers? What is the 10th position for all these numbers? For all these above numbers, what is the 10th position? 0.
0.
So that means you kept the first number 0 in the place, and you are varying okay. So you are varying this unit digit with all possible values 0 to 9. After that, we fix 1 here, and we will vary the unit digit with all possible values. Okay. So we will vary the unit digit again with all possible values. 0, next 1, 2, 3, 4, 5. So like that, we do it up to 90. We did it up to 19. So after 19, again what we are doing? We are fixing the 2 at the 10th place. Again we are repeating the unit digit. Okay. So like that, how long we are doing like that? Till 99. 99. So you are fixing the first digit in the 10th place, and the unit digit is varying every time. So next 1 is fixed in the 10th digit, varying 0 unit digit 0 to 9. So like that. So once we reach to the fully, all the unit places were filled with all possible values, and all the 10th digit also filled with all possible values. Then what we are doing? The next value. So we are making this as 100. That means 100th digit. So for all these above 99, 100 values, the third digit will be 0. So in that way, we will form the numbers. Okay. So again, we will fix a 1 here, and we will get 100 values, 0, 0 to 99 in this place, 10th and so in that way we will form the number system. Not only the decimal number system, even all the other number systems will also be formed like that only. Okay. So like that only other number systems will also be formed. So now we'll try to, with this concept, we'll try to form the binary number system now. Okay. So how many digits are there in the binary number system? Only 2, 0 and 1. 0 and 1. So once we reach to the maximum values, what we are doing? So next, so in these cases, the second digit is 0. For these two values, the second digit, this digit is 0. Now what we'll do? We'll put 1 in this place, and then again unit digit we will change it as 0 and 1. Okay. So now we reach to the maximum. Both the digits, 0th digit and the first digit, both digits reaches to the maximum. So in that case, what we do? We introduce the third digit. So for all these 4 values, the third digit is 0. And then we'll fix 1 in the third digit. Again, we vary these values from 0, 0 to 1, 1. These values will vary from 0, 0 to 1, 1 by fixing 1 in this place. So like that, you can observe how this number is formed. See, this last bit, least significant bit, we say. So the power of this is a binary number system. But binary number system base is 2. So this is the 0th place. So the coefficient of this will be 2 power 0. Okay. So 2 power 0 is nothing but 1. So 2 power 0, the coefficient is 2 power 0. 2 power 0 is nothing but 1. Okay. So that means this particular, this bit, this unit digit bit will flip every time. Every time it will flip. So first time if it is 0, next time it will be 1. Next time 0, next time 1, next time 0. So every time it will flip. Okay. So whereas for the second position, so this 10th position, so the coefficient will be 2 power 1. So 2 power 1 is nothing but 2. So that means this digit will vary for every 2 times. This second bit, this will vary for every 2 times. That means first 2 are 0, next 2 are 1, next 2 are 0, next 2 are 1. So like that, for every 2 times it will flip. Okay. Whereas for this 100th digit, so this is 2 power 0, 2 power 1, this will be, coefficient will be 2 power 2. So 2 power 2 means 2 power 2 means 4. 2 power 2 is 4. So that means this bit will vary for every 4 times. So first 4 zeros, next 4 ones, again next 4 zeros, next 4 ones, like that every time, every 4 times, every 4 times that bit will be flipped. Okay. So the next bit will be flipped for every 8 times. That is a coefficient of 2 power 3. So which is nothing but 8. So every time, every 8 times the 4th bit will change. So now I am writing a binary number with the 4 bits. How many values we can able to represent, we'll see. Okay. So this 4th digit will be same for first 8 numbers. So 8 zeros here in this place. will have 8 zeros and these values will vary. Now we'll get the same values by placing the fourth bit as 1. So by placing the fourth bit as 1. So for the next 8 values, this fourth bit will vary, will be fixed as 1. So if you observe, this unit bit will change every time. It will be flipped every time because the coefficient of this is 1. So this second bit vary for every 2 times. Okay, whereas this third bit will vary flip for every 4 times, whereas this bit will vary for every 8 times. So this we call it as 0 in the binary, in the decimal number system. This is called 0. Okay, this is 1. Okay, so like that, this is called 15. So you need to know how to write the first 50, 0 to 15 binary numbers. Okay, you must and should know the values of all this. Okay. So in that way, binary number system will be formed. So same way, how the octal number system will be formed? Oct means 8. Oct means 8. So we'll have the digits 0 to 7. Any number which is formed using the digits 0 to 7 is called an octal number. Okay. Say for example 345. So this 345 is also, we can call it as a decimal number, and it is also in the range of octal. So how to distinguish between a decimal 345 and octal 345 is, the decimal 345, say for example, if this is a decimal number, we simply say that 345. So whereas if it is an octal 345, it will be preceded by 0. If you write it as 0 345, or that we treat it as octal. So the number which is represented here is an octal value. Okay. Suppose if it is represented as 0x followed by 345, then this is treated as a hexadecimal form. So simply, without any precedence, if you specify, that is a decimal. This is a decimal number. This is an octal number. This is hexadecimal number. Okay. So any number which is formed using the digits 0 to 7 is called an octal value. So can you tell me the first 15 values in the octal quickly? So 0, 1, 2, 3, 4, 5, 6, 7. After that, 1, 0. Okay. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. After that,
2, 0.
2, 0, 2, 1. So like that, octal number will be formed. Okay. So
Yes.
next, hexadecimal value. Hexa means 16. Hexa is nothing but 16. So any number which is formed using the digits 0 to 9, so total 10 digits, plus A to F. A to F. It can be either capital A to F or small a to F, no problem. So these are the six values. So that means 10 is represented as A. Okay. 11 is represented as B. So like that, 15 is represented as F.
F.
Okay. So it can be a small f or capital F, no problem. Okay.
Yes, ma'am.
Small a, b, c, d, or So these are the number systems which can be recognized by your computer. So this is a binary, this is a decimal, and this is an octal number system, and this is a hexadecimal number system. Okay, so now we'll see how to convert one number system into another.
Okay, ma'am.
Okay, so now let me convert any number. We know the decimal number system very well. So we'll start with that. So to convert decimal to any other number system.
Okay. Decimal to any other
Number system. So first we need to know the base of each number system. Decimal means 10. So binary means 2, oct means 8, hexadecimal means 16. So if I have, say, 345, this is a decimal number system. Now I want to convert this into say binary. Suppose I want to convert this into binary, then divide this with 2, take the remainder. Divide this number with 2 and take the remainder. So again divide till you get a coefficient value as 0. Okay, suppose you want to convert this into an octal number system, base is 8. So divide with 8 and take the remainder till you get a coefficient as 0. Same, if you want to convert this into hexadecimal, because hexadecimal base is 16, you divide this with the 16 and take the remainder till you get the coefficient value as 0. So we'll do it. That.
Okay, ma'am.
Okay. To which number system you want to convert? You divide the number with the base of that number system. Okay. So
Yes.
suppose I am taking say 345. So this is my number. Okay. Now I want to convert this into binary, say for example. So you divide with 2. So what will be the coefficient? 1 time, 14 means 7 times, 5 means 2 times. I left out with a remainder of 1. Okay. Again you divide with 2. So 8 times 16, 6 times 12, remainder is 0. Okay. Again you divide with 2. So like that till the coefficient becomes 0, you have to do it. Okay. 4, 3. Remainder is 0. Again divide with 2. It will be 2, 1, remainder 1. So again divide with 2, 1, 0, remainder 1. Okay. Again divide with 2, it will be 5, 0. Again divide with 2, it will be 2 times and a remainder of 1. Again you divide with 2, that will be 1, 0, either 0 or 1. So okay, so now you reverse these values. So if again I divide, I'll get 0 and remainder as 1. So now you write these digits in the reverse order, these reminders in the reverse order. Okay, reverse order. So that means 1, 0, 1, 0, 1, 0, 1, 0,
1,
1, 1,
0, 0,
0, 0,
1.
1. So this is the binary equivalent of 345.
345.
Okay. Suppose you want to convert this into octal. So then what you need to do? Instead of 2, you divide with 8 and take the remainder. Okay. Suppose you want to convert this into hexadecimal, divide with the 16. Okay. So let us, I think you understand the process. So to convert a decimal number into any other number system, divide your decimal number by the base of the other system which you want to convert and take the remainders till you get a coefficient value as 0. Okay. So then you write all the reminders in the reverse order. You write all the reminders in the reverse order. So the one which you got is nothing but the equivalent number system. Okay. So this is the process to convert a decimal number into binary. Okay. So 345 base 10 is equal to 101011
011 001
001 base 2. This is binary equivalent. So like that you can convert into octal and hexadecimal also. So we got the process. Okay. Divide with
the given number.
base of the
Given
number system which you want to convert.
Yes.
Which you need to convert. Okay. So next we'll see the process of how to convert other number system into decimal. Suppose you are given a binary, how to convert to decimal, or suppose you are given a octal, how to convert to decimal. You are given a hexadecimal, how to convert to decimal. So other number system to
decimal.
How to convert this. Okay. So here again what we do is, say for example, I have 101011. Suppose this is my binary number. So I want to convert this into decimal. So in that case, what we'll do is, so you take, this is nothing to, because this is a binary number system, the coefficient of this digit will be 2 power 0. The coefficient of this digit will be 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. So like that, you have to multiply that bit into its power, like coefficient. Each bit you multiply with its coefficient. So 1 into 2 power 0 plus add all those values. Now again this bit is 1. So 1 into 2 power, the coefficient of that is 2 power 1. Okay. Plus, and the next bit is 0. So 0 into 2 power 3 plus this bit is 1. So 1 into 2 power 4 plus 0 into 2 power 5 plus 1 into 2 power 6. Okay. So this into 2 power 0, this bit into 2 power 1, this bit into 2 power 2, next bit into 2 power 3, next bit into 2 power 4, next bit into 2 power 5. Okay. So now you find the equivalent. 2 power 0 is 1. So 1 into 1 is 1. 1 plus 2 plus 0 into anything is 0 plus 8. 2 power 3 is 8 plus 0 plus 32. 32. So that will be equal to
43.
So 11 plus 43, 32, 43. Okay. So the decimal equivalent of this binary number is nothing but 43. Okay. Suppose I have a value in octal, say 203. The base of this number system is 8. Okay. So to say that this is an octal value, how we'll write 0203. Okay. So this is an octal value. Now try to convert this into decimal. So the base of this octal number system is 8. So how we'll write 3 into 8 power 0, 8 power 0 plus
0 into 8 power 1.
Yes.
Plus 2 into 8 power 2. Plus 0 into 8 power 4.
Plus
What?
2 into
2 into 8 power 1.
3 into 8 power 0, 0 into 8 power 1
2
plus
into 8
2
power
into 8
8
power.
power 2.
So this 0 is not the part of the number system. To say that this is an octal value, we have included this. Okay. So the equivalent is 3 plus 0 plus 16 twos are 32. Sorry, 68 8s are 64. 64 twos are 128. So which will be equal to 131. So the octal equivalent of the decimal equivalent of 203 is equal to 131. Okay. Suppose you are given a hexadecimal value. So then you multiply with the 16 base, 16 power 0, 16 power 1, like that. Okay. So that is how to convert other number system to decimal. Decimal to other number system to decimal. Now we will see binary to other and other to binary. You switch off your mic. There are a lot of sounds. Okay. Okay. So suppose binary to other. So already we have seen binary to decimal we have seen. We will see the other two, how to convert a binary to octal. Okay. So 1010, some values I am taking. Okay. So suppose this is the binary value. Now I want to convert this into octal. What is the octal value for this binary? Okay. So oct means 8. 8 means it is nothing but 2 power 3. 8 means 2 power 3. So in binary, the base is 2. So you take every 3 bits of your binary number from right to left, least significant to most significant. So if this is called least significant bit, this is called most significant bit. Okay. So from least significant position, you divide this whole number into 3 bits. Okay. So let me write. So the division. So first one is 110. So that is the first division. I am using a space to distinguish the division. So next division is 101. Okay. Next division is 010. Okay. So first these 3 bits. Next 101. Next 010. Next one is 101. Okay. It need not be the equivalent. Maybe suppose you think that I have one more digit here. Okay. So in that case, here I have left out with only 1. So you put zeros, preceding zeros. So because preceding 0 doesn't have a value, So you can use preceding zeros for the last grouping. Okay. So if the last grouping doesn't have a sufficient values, sufficient 3 numbers, if you didn't have a 3 digits, so in that case you add sufficient zeros to get the 3 digits. Okay. So I have taken this. So because only 1 digit is left out, so I am adding the other 2 as zeros. Now you convert this. Tell me the decimal equivalent of octal equivalent of these values. 001 means 1. 101 is nothing but 5. 010 is nothing but how much? 2. 101 is nothing but 5. 110 is nothing but 6. Okay. So this is nothing but 1. This is 5. This is 2. This is again 5. This is 6. Okay, write the decimal equivalent of that. Octal means octal equivalent only, because all these values are 3 bits. So the maximum value you will get is up to 7. So 0 to 7 only. Okay. So this is the octal equivalent of this binary. Have you got it? If you want to get the octal equivalent of a binary number, you divide the number into 3 groups, bits, 3 bits of each group.
Why you to take that 00 in front?
Yeah, here it is like this. It is like this because I said in each group you put to three digits, because
Okay.
this doesn't have a 3 digits. I have added preceded
Okay.
because preceding 0 doesn't have any value.
Yes, ma'am. I understand.
Okay.
Yes.
So that is how to convert a binary. So we have already seen here how to convert a binary into decimal. Here we have seen the simple process how to convert a binary into octal. Now we'll see how to convert a same binary number into hexadecimal. Hexa means 16. Hexa means 16. 16 is nothing but 2 power 4. 16 is nothing but 2 power 4. So 2 power 4 means now you divide this binary number into 4 bits. Each group consists of 4 bits. Okay. So
Yes.
now, so first group is 110. Okay. Next group will be
1010.
1010. Okay. Next group is 1010 again.
Yes.
Next group consists of only 1 bit.
Yes.
Okay. 4. So it consists of only 1 bit. You make the same way, preceded by zeros to make it. Okay. So now you write the decimal equivalent of each 4-bit decimal equivalent. So 0001 is nothing but 1. 1010 means, so this is 2 and this is 8. 8 plus 2 is 10. 10
Right.
means A. How the 10 is represented in hexadecimal? A.
A.
Again, this is A.
Yes.
And this is, what is this value? 2 plus 4 plus 8. 12. 14.
Yes.
So 14 means D. Sorry, E. 14 means E. 15 means F. Okay. So 14 means E. This equivalent is, hexadecimal equivalent is E. So this is the equivalent, hexadecimal equivalent of this binary number. So you divide, to convert binary into hexadecimal, you divide the binary number into 4 groups. Each consists of 4 bits. Okay. Now you convert these 4 bits to its hexadecimal equivalent. Okay, that's why I said you should know the binary and decimal or decimal equivalent of first 15, 0 to 15 binary values. Okay, so then you can able to convert the, so if you know from 0 to 15, you can quickly convert this. This is 10, this is 10, this is 14. So that you can able to quickly identify it and then quickly able to convert it. So this is how to convert a binary number into other number system, decimal, octal, and hexadecimal. Now we'll see how to convert the other number system into binary. Okay, we have already seen how to convert a decimal to binary. Now we'll see how to convert octal to binary. Octal to binary. Suppose I have a octal 234. So this is my octal value. How I need to convert this into binary is, it is so simple. So each bit, each digit of your octal, you represent the 3-digit 3-bit equivalent in binary for each digit in your octal. So that means 2 for 2. So this is to represent that this number is an octal. I have used that 0. Okay. So the octal value is 234. Now to convert this into binary, what you do is, first you represent each digit in your octal, you represent it in binary using 3 bits. So how to write 2 in binary? 0, 1, 0. Each number, each digit, you need to represent it using 3 bits. Octal to convert to octal. Sorry, to convert octal to binary. Okay. Next 3. 3 means how will you represent 3 in binary? 1, 1. So 0, 1, 1. 4. 4 means 1, 0, 0. Okay. So this is the binary equivalent of this octal value. Binary equivalent of this octal value. Suppose I want to convert a hexadecimal number into binary. So in that case, each digit you represent it using 4 bits in binary. Same method. Okay. Suppose I have 4A C6. Okay. 4. This is my say for example, this is my hexadecimal number. So to convert this into binary, now you represent each digit of your hexadecimal in 4-bit binary equivalent. So 4 means 0, 1, 0, 0. This is 4. 0, 1, 0, 0. A means 1, 0, 1, 0. 10. 10 how will you represent in binary? 1, 0, 1, 0.
1, 0, yes.
C. C means, so 1, 0, 1, 0 is 10. 1, 0, 1, 1 is 11. Okay. 1, 1, 0, 0 is a C. 12.
12.
C means 12. 12 is represented as 1, 1, 0, 0. Okay. Now how the 6 is represented? 6 means 2
0,
plus
1,
4.
0,
0, 0, 1, 1, 0.
1, 0, yes.
Okay. So this is the binary equivalent of this hexadecimal.
Ma'am,
Okay.
is it mandatory to remember if we don't know that A is equals to 1010? Then
That's why I told you, you have to must and should learn, like you can form it in the rough. First,
No,
I
ma'am,
told you how to form the number system.
my question is ki,
Yeah.
if we, in case if we don't know about A equals to 1010,
Yeah.
then can't we convert this binary to octal or binary to hexadecimal?
Yeah, you can do it. First, you convert into decimal. After
Okay.
that, you convert into binary.
Okay.
Okay. First, you convert this into decimal, and then decimal to binary, or like other number system and other number system to binary. Like that also you can do it.
Okay.
But always we need to remember this 0 to
15.
15.
Okay.
That will be better. Okay.
Okay.
So not only better, you have to, must and should, because later also we encounter this concept. If you don't know this, that will be a negative point to you. You will be lagging back. Okay. So must and should, we know the conversion of from 0 to 15, the decimal equivalent of your binary numbers. Okay. Okay, so this is how to convert. So if now, how to convert? The only thing that we left out is octal to hexadecimal, hexadecimal to octal. The better way to do that is, first you convert your octal to binary, and that binary you convert into hexadecimal. Same way, hexadecimal to octal, first you convert hexadecimal to binary, and that binary you convert into octal. So that is a simple way to convert. Okay, so I think I have discussed everything, every number system to every other number system. Okay, now we'll answer some of the bits, and then okay, so let me discuss even the how to represent the negative values in computer. How to represent the negative values in computer. Say for example, -5. Suppose if it is a 5, how it is represented? 0, 1, 0, 1. 101, you can see. 101 is the binary representation of 5. Okay. Suppose if it is a -5, negative values. How the negative values will be represented in computer is, it is represented in
complement.
2's complement form.
Okay, 2's complement. Sorry.
Okay, so the negative numbers are represented in its 2's complement form in the computer. So how to get the 2's complement is 1's complement plus 1. So 2's complement equal to is nothing but 1's complement plus 1. That is the 2's complement. 1's complement. So how to get the 1's complement is, interchange 1's as zeros, zeros as 1's. That you will get the 1's complement. Okay. So first you try to represent this. So here our number is represented using either a 32-bit or a 16-bit. So like that you can represent it in using how many bytes you are using to represent your value. Based on that it will change. Okay, so think that I am using a 8-bit representation, for example, or 16-bit representation I am using. So in memory, that means integer is represented using 2 bytes. Byte means 8 bits. So 2 bytes means 16 bits. So every number is represented using 16 bits, you think of every decimal. Okay, so I am using that notation. So first how we represent 5 in 16 bits is, we know that 5 is 101. So to get the 16 bits, you add zeros, preceded zeros. Okay, 0, 0, 0, 0. So 8 bits, 0, 0, 0, 0. 12 bits, 0, 0, 0, 0. So this is nothing but 16-bit representation of 5. Okay, so all preceded zeros I have added. That doesn't have any value. So this is equivalent to 5. So -5. Now what I want to represent? I want to represent a -5. So -5 means it is represented in its two. So negative numbers. See here, to represent a negative value, we always try to represent the value. This most significant bit is used for sign. This most significant bit is used for sign, and the remaining bits are used for representing the data. All these bits are used for representing the data, whereas this most significant bit is a sign bit. Okay, sign bit. If you have a 0 here, that indicate it is a positive value. If you have a 1 here, that indicate it is a negative value. If in most significant bit, if you have a 1, that indicates that that is a negative number. Okay, whereas only we represent the data in these bits. Now find the ones complement of this. Ones complement means wherever you have a 0, you put 1. Wherever you have a 1, you put 0. So this is the ones complement. This is the ones complement of this value. To this you add 1. Ones complement plus 1. You add 1. Okay. So 1 plus 0. So 1 plus 0 is 1. 1 plus 0 is 1. And the remaining are zeros. Here you have a remaining are zeros. So if you add 0 to the previous value, you will get the same value. So 1 1 1 1 1 1 1 1 1 1 1 1 1 0 1 1. So minus 5 is represented as, in its 2's complement form, it is represented like this. Okay, we'll see once. Okay, we'll answer this. You encounter that first. So try to answer the questions. 877 base 10 is equivalent to dash base 2. You are asked to convert this into binary. So what we need to do? Divide 877 by 2. Take the remainder. Okay. Definitely first 2 will not be the answers. Okay. So first 2 will not be the answers, because if you convert into binary, you will get only ones and zeros. Okay.
And the third one will be the answer.
Yeah. So you try to convert this. So the last bit, 877, try it. $877 divide with the 2. So you will get 4 3 8. Remainder is 1. Again divide. So 2 2 1 9. Remainder is 0. So if you check the options, four, okay, 2 1 0 4. Remainder is 1. 104. Is it correct? 1 0
109.
9. Sorry, 109. Remainder is 1. So 2 5 4 5 4. Remainder is 1. So if by seeing these bits, you can see in the last 1101, which option is having 1101. From that you can
Third
identify.
option.
So this
Third
is having 1101 in the least significant. So you can strike off this. Without doing completely also, you can select it. Okay. So next, consider a 10-bit integer number using a signed magnitude concept. Signed magnitude concept means the most significant bit is used for sign, whereas the remaining bits we use it for representing the data. That is a signed magnitude concept. Okay, identify its positive and negative ranges. Okay, so 10-bit integer. 10-bit integer. So 1 bit out of the 10 bits, 1 bit is used for sign. 1 bit is used for sign. The other bits will be used for representing the data. So how much big number you can able to represent?
9.
2 power 9 to so because in the positive side you will get 0 will be added to the positive side only. So you will get up to 2 power 9 minus 1 only. 0 to positive side you will get 0 to 2 power 9 minus 1, whereas in the negative side minus 1 to minus 2 power 9 minus 1. Okay, so this is the correct range. A positive range is 0 to 2 power 9 minus 1 to negative is minus 1 to minus 2 power 9 minus 1. Okay.
Okay, ma'am.
Which of the following ranges describes the negative range for a 32-bit hexadecimal representation using 2's complement notation? So I said 2's complement notation means negative. For negative values, we represented 2's complement notation. So negative range they are saying. So for negative numbers, the 32 bits we are using, the most significant bit will be 1. Okay, for the negative range, see here, I need to represent 32 bits.
What is this meaning of range of 32-bit number?
Yeah. Okay. Wait. First, let me discuss. Suppose I have taken only 1 bit. 1 bit. So, how many different values you can represent using 1 bit? That 1 bit can be 0, or that 1 bit can be 1. So, 2 different values you can able to identify if you use only 1 bit. Suppose I have taken 2 bits. How many values we can identify?
4.
1, 2, 3.
4. It can be 0, 0, 0, 1, 1, 0, 1, 1.
1, 1.
So 4 different values you can able to, like if you take 2 bits, you can able to represent 4 values. So like that, if you take 10 bits, how many values you can represent? That is the range. That is nothing but the range. So if here what we are saying, that is a signed magnitude number. That means suppose think that I have taken 5 bits. Let me take 5 bits. So out of 5 bits, this bit is the sign bit. This bit is a sign bit, and only you are representing the data using 4 bits. So using 4 bits, what is the maximum value we can represent using 4 bits? 15. 15. So if this is 0, we can, on the positive side, you can represent 0 to 15. Whereas in the negative side also, you can represent another 15 values. Okay. So minus 1 to
15.
Minus 15. So that is the range.
Madam, minus 16 or minus 15?
Let us see. Let us see.
It will be
This is
16.
No. It will be 15 only. I'll tell you. So because negative side, this bit will be 1. Okay, most significant. So in the remaining 4 bits, the maximum value you can represent is 15 only. Okay.
Yeah,
Or
but
can
zero
you-
we have already represented, no, madam.
No. Here, see, in using these 4 bits, how much value you can able to represent?
Maximum of 50.
Maximum value that you can represent using only, this is the data bit I am saying. This is the data representation. Maximum value you can represent using those 4 bits is?
Ma'am, 16 values can be represented, but maximum value will be 15.
Will be 15. So this can be maximum, it can be minus 15. Okay. If it is a signed magnitude form, I am saying. If it is a signed magnitude form, this most significant bit will always represent a signed bit, and the remaining 4 bits are used for data. So using 4 bits, maximum you can represent is 15. So this side, negative side will be minus 15, positive side will be plus 15. So that's why previous bit also we have answered like that only. 0 to 2 power 15. 2 power 10 bits is said now, so 9, 2 power 9 on the positive side, whereas negative side it will be from, because minus 0 and 0 are same. If you say 1 after that 4 zeros, so minus 0 and 0 are same, so we need not consider the minus 0 and 0 as a different values. So
Yes.
that's why we are representing minus 1 to minus 2 power 9. Minus 1 to minus 2 power 9. So this is the range of values that we can represent on positive and negative sides if we take a 10-bit signed magnitude number. Okay. So now we are given 32-bit hexadecimal representation. What is the negative range? They are asking. So negative, say 32 bits if you take. So let me take. This is a 32-bit. Hexadecimal. Okay. See, hexadecimal, each digit is represented using 4 bits. 4 bits. So I've written here, I think this 8 4s are 32. So this is the, so this, if you think that all these are hexadecimal numbers, so each bit is a hexadecimal bit if you say. So always this bit will be, so most significant bit will be out of 32, negative side they have asking. So the 32 bit will be 1. The 32 bit will be 1. And 31, 30, 29 bits will be 0, 0, 0. After that, the remaining are all zeros you can say, or all Fs you can say. So in that case, what will be this value? This will be 8. This will be, see here, in the hexadecimal form, 1000 means it is 8. So this will be the range. 8000002 F, all Fs. Okay, negative side range is this. Suppose you have a document which contain only uppercase alphabets. Your document contains only uppercase alphabets. How many bits are required to encode a character such that the size of the document is minimum? Okay, so uppercase alphabets, how many are there? How many uppercase alphabets are there?
36.
26.
26.
Alphabets means ABCD. So it is Z, only uppercase, capital ABCD. So you have a 26. So to represent 26 values, how many binary digits we require? Suppose if you have 1 bit, it can represent a maximum of 2
Five.
values.
Five
Suppose
binary
2 bits, 4. Suppose 3 bits,
8.
8. Okay, 8 values you can represent. Suppose if you take a 4 bits, you can
16.
maximum values you can represent 16. 5 bits you can represent 32. So that will comes under this range. So minimum number of bits because you are given a 26, which is more than 16 and less than 32. In this range it will have. So always we will take the higher side. So minimum 5 bits are required to represent that document, all the alphabets in that document. So you require 5 bits.
Excuse me,
Ma'am, how one bit can represent 2 letters?
Just we have 0. So suppose we have only 1 bit, that bit can be 0 or that bit can be 1. So these are the 2 different values that are represented using 1 bit.
Okay.
Suppose
ma'am.
there are 2 bits, 0 0, 0 1, 1 0, 1 1. 4 values you can able to 4 different values you can represent. Say suppose
Okay, ma'am.
if okay, you got it. So like that, if it is if we need to represent only uppercase alphabets, we require minimum 5 bits.
5.
Okay.
Ma'am, hello.
Yes.
Ma'am.
Yeah.
How you are saying this thing, because if it is number, then we understand that to store a 2 or 4 we need 4 bits. But it is an alphabet, so on what basis you are saying?
See, everything in your computer can understand it in only using binary digits. So every alphabet or a digit is converted into its ASCII value. ASCII values chart will be there. So everything is given one code. Okay. So capital A means it is, I think, 65. The capital
65,
A.
Yes, ma'am.
The code, ASCII code of the capital A is 65.
65.
So how many bits are required to represent 65?
7.
Like that. Binary. Everything is represented in the binary only. Then only your computer can understand. So whether it is an alphabet or a digit or any quote, a single quote, double quote, or semicolon or hyphen, whatever it may be, any character in your keyboard is represented in numerical form in ones and zeros only. Every character will have its equivalent integer value in C language.
Yes, ma'am. But what I understand, you said if I want to store, then its ASCII value will be 65, right?
Yeah.
So
But here you read the question. Your document contains only alphabets, no other letters. Uppercase. Your document contains only uppercase alphabets. Okay, that means
alphabet means A only, no? Capital A, right?
Yeah, capital A to capital Z.
Yeah.
You need to recognize.
So let's say if I want to store only capital A, so capital A ASCII value is, as you told, 65, right? And to store 65, we need minimum 7 bits.
Yeah,
right?
no. Actually, in that case, I said to recognize all the characters of your keyboard, it will take the ASCII value. But here, our scenario is we need to design a processor which should recognize only uppercase letters. We need to design a processor which should be able to recognize only uppercase alphabets. How many uppercase alphabets are there?
Yeah, that is 26.
26. So minimum we require only 5 bits to, so you can assign 0 to A, 1 to B, 2 to C. Like that you can assign values up to 26 only. The remaining 4 or 5 values will be wasted.
So it is asking number of alphabets, right? Not alphabet.
No. Only you here when we use the ASCII value is because in your keyboard you have your language. Your language consists of suppose 255 different characters. Suppose think that you in the world, to recognize your language, there are 255 different characters are there, whether it is a digit or a comma or a semicolon or some other symbol, whatever it may be. Suppose 255 are there. In that case, we, for that encoding, we go for the ASCII chart. Okay. So, but here what he is asking is, you need to recognize 26 different letters. Okay.
Yes.
Only you need to recognize only 26 different letters. So
One
how
question.
many minimum? Yeah.
Question has already told that you can create your own encoding method.
Yeah.
It means we don't have to follow ASCII value.
ASCII values.
No,
But
let's
you
suppose
asked
if I am
how
following ASCII
it is a character, how to, for that I gave the answer as you have to take, for every character there will be equivalent integer value, you need to take that ASCII. But here you can use your own encoding method. That means you can represent capital A as 0, capital B as 1, capital C as 2. Like that, you have to recognize all the 26 letters, their codes. So maximum to recognize 26 letters, how many bits, minimum number of bits that are, even you can have 7 bits or 10 bits also you can have. But here he is asking minimum number of bits that are required. Okay. So the minimum number of bits that are required to recognize 26 alphabets is 26 letters, so 5 only. Okay. So next, let's see. Which of the following assembly level instructions can be used to store a value 0 in a register named R2, assuming R0 always holds a value 0 and R1 always holds a value 1? Okay. So in the previous class, we have discussed how your registers will work. Okay. So registers are used to store some temporary values while performing the operations. So move operation, what the move will do, it will move this value to this register. Okay. Add means it will add these two values, that result it will store it here in this. Okay. So add is having 3 operands here. So add, what it will do is, these two values will be added and that result it will store it in this third. Again, subtract. So R1 and R2 gets subtracted and that result it will store it in R2. Okay. So add means it will add these two values, add immediate instruction it is. So these two values will be added and that result again it will store it in here. Okay. So that is these commands what they will do. So we are given that.
First two.
Yeah. So we'll see the result. So R0 holds a value 0, R1 holds a value 1. That is given. So what we are doing here, 0 is moved to R2. So what we are asked, you should get 0 in register 2. So this will move the 0 to register 2. This command will store 0 to the register 2. So that is correct. Next, second one is, so add these two values gets added and that it will store it in R2. So 0 plus 0 is always 0 and that 0 is stored in R2. So this will also make R2 to 0. And subtract. So R1 minus R0 is 1. So R1 is 1, R0 is 0. So you will get 1. So that R2 will have a 1 here. The subtraction of R0 and R1 will be 1. So in this case, your R2 contains 1, but we require R2 must be 0. So this option is wrong. And here also add immediate. R1 is added with 0. So R1 contains 1. 1 plus 0 is 0. Sorry, 1 plus 0 is 1. So your R2 will contain 1 in this case. Okay. So these two options are wrong. So only in these two cases we will have R2 as 0. Okay. So the first two options are correct.
Ma'am,
Yes,
can you take example of third one,
third one.
third
Yeah.
option?
So that is a three address instruction. Three address instruction. So the meaning of this is you add these two values. That result you store it in this third register. Okay.
Ma'am, I have a doubt that
Yeah.
this addition, subtraction are algebraic addition or subtraction, right?
Yeah.
It's not a binary addition.
No, it is not a binary addition. It is algebraic addition only, I am saying.
Okay.
So R0 is 0. R1 is 1. So 0 plus 1. 1. 1 is stored in R2.
R2.
Have you got
Okay,
it?
ma'am, got it.
Okay.
Now, in that case, madam, if add R2, R1, R1, what will be the answer?
R1, R1. So
Yeah.
R1 is 1, 1. So it R2 will be 2.
It will take as 2 or it will
So it will take it as a 2 only.
binary.
Inside it will store it as 1, 0. Answer is
Okay.
2 only. But inside while storing, it will be stored as 1, 0.
Okay,
1,
madam.
0 is equivalent to 2.
Okay, okay.
Okay, here we need to consider only the decimal addition only. We need to tell it as an answer. Inside a computer, how it is representing is different. Okay. Next, collection of 4 bits is called a nibble. Okay, but word means 32 bits, byte means 8 bits, nibble means 4 bits. File is nothing; it can have any number of bytes. Yes.
In the earlier example, comma is required, right? No comma.
The early example.
Third one, comma is
Yeah.
required, right?
Comma. The instruction will depends on the processor, microprocessor which we are using. See here, these are the mnemonics used in a particular language, microprocessor language. Okay, so you don't consider the syntaxes and all. You just know the meaning of these mnemonics. That's all. That's enough. Okay, these will change. These will change based on your processor. Add immediate. ADDI means add immediate. Here, the difference between add and add immediate is generally here we may represent an address. In this case of add, this can be one of the address. This can be one of the address. The value at this address and the value at this address gets added. Maybe immediate means you will have a data instead of address. I think in this case, no difference between add and add.
Then ma'am, how processor will understand? We can write instead of R1, we can write R1, R0. R2.
Actually, here they have not specified that these instructions are under which processor. Just an assembly level instruction they gave. Just okay. Just you read it as some mnemonic which has this meaning. Okay. So don't consider that, because if you are given a specific to 8086 or 8088 processor like that, so in that case we need to consider the corresponding mnemonics. Here we used pseudo value, we used it might be different for different instructions. In some of the processors you will have a microprocessor, you will have only add means A, like L, load means L. Like store means yes, like that.
I mean to say, is there any processor family is there that will work on third instruction?
Yeah.
Without comma?
Yeah. Even some
Which processor family now?
I can't even exactly mention. But here you don't consider the syntax. because here there is no option that this syntax error. Okay, you can even think of like that. You consider only the mnemonic of this and work out accordingly. There are some instructions which have only 2 values here. Instead of 3 operands, you will have only 2 operands. In that case, those 2 get added and the result again stored in the first one.
So if it is 2 also, comma is not required?
Yeah, in general we use comma. In general we use
I
comma.
meant to say, ma'am, is there any processor that will work without comma?
May not be.
Okay, ma'am, got it. Thank you, ma'am.
So collection of 4 bits is called a nibble. So word means 32 bits, byte means 8 bits, nibble means 4 bits. File, maybe it can have depends on the size, how many values how many characters we are storing in the file. Based on that, those many number of bytes will be the size of the file. Okay. What is the decimal equivalent of this binary number? So till now we have discussed only the, we have not discussed the fractional part. Okay, only the real part only we have considered, and then conversion is done. So now how to convert this fractional part, we'll see. How to convert this fractional part into decimal. Okay, so the same way how we did in case of, so this is the what we need to convert. So this is nothing but, so this is 2 power 0. Coefficient of this is 2 power 0. This is coefficient of this is 2 power 1, 2 power 2, 2 power 3. No. So this will be, the coefficient will be 2 power minus 1. The coefficient will be 2 power minus 2, 2 power minus 3, 2 power minus 4. Like that. So this will be equivalent to saying, so 1 into 2 power 0 is 1. Okay. 1 plus 2 plus 0 plus 8. Okay, so that is a
11.
value before the decimal place, so that will be 11. Okay, and after the decimal place, how we will write the coefficients is 0 into 2 power minus 1. 2 power minus 1 is nothing but 1 by 2. 2 power minus 1 is nothing but 1 by 2 plus 1 into 2 power minus 2. Minus 2 means 1 by 4. Okay. Plus 0. 0 into anything is 0 anyhow. So plus 1 into 2 power minus 4. 2 power minus 4 is nothing but 1 by 16. Okay, so in this is 0. So you will get the final answer, which should be 1 by 4 plus 1 by 16. How much it will be?
5 by 16.
1 by 4 is nothing but 0.3125. 0.25. 1 by 4. So what is the value of 1 by 16?
0.
0.0625. Okay, 0.0625. 0.625. So you add these two now.
312. 0.3125.
Point.
312.
Oh, wait. Let me write. 0.0625. 0.2500. Okay. After decimal point, further 0 doesn't have the value. Before decimal point, this prefix value doesn't have the value, prefix 0. Okay. So it will be 5, 2, 11, 3. Okay. So 0.3125 will be the after decimal point. Before that is 11.3125. So the last option. Have you got it? The same method. This is coefficient of 2 power 0, 2 power 1, 2 power 2. So if you come to this side, it will be negative. This is coefficient of 2 power minus 1, minus 2, 2 power minus 3, 2 power minus 4. Coefficients will be negative. Yeah, same method we use it for even octal and hexadecimal also. See, if you have octal, this 8 power minus 1, 8 power minus 2, like that you have to take.
Excuse me, ma'am.
Yeah.
Ma'am, why did you start it from 1 by 2? I mean, why the first is 2 power minus 1? You have explained it, right? Can you open notebook again? Yeah, why you started?
Yeah, see, this is 2 power 0. Coefficient of this bit is 2 power 0. So after decimal point, it will come to the negative side. 0, the immediate negative value will be minus 1. This is coefficient of 2 power minus 1. So 0 into 2 power minus 1 means 1 by 2. How will you write x power minus 1?
Yeah, that's but ma'am,
1 by x.
ma'am, left side to decimal, we are starting from 2 power 0, right?
Power 0, 0, 1, 2, 3. When you go to the left side, it will be increasing. When you go to the right side, it will be decreasing.
Yeah, that's okay, ma'am. It is going from 0 to 1 to 3. No, why?
No. It will 0 is always in the positive side. Negative side, it will be from minus 1.
Ma'am, is there any reason behind it?
No, the 0, negative 0 and positive 0 are same, no. So there is no negative 0. There is no minus 0 exists in the number system. There is no minus 0 exist in the number system. 0 means positive and negative is 0 only.
Ma'am, he is saying, why are you not considering the values after decimal starting from first digit to left side?
Yeah, that only I am saying. Always see, there is no minus 0 in the number system. Okay.
Ma'am, it's like
so negative number means it will start from minus 1 only.
Ma'am, it's like first number before decimal will be 0, and if we are going beyond
left
decimal,
side, it will be positive, 1 increase. If you go to the right side, 1 decrease.
Okay.
0 minus 1 is minus 1 only, no?
Yes, ma'am.
So if you go to the right side, it will be minus 1, minus 2, minus 3, like that. If you go to left side, it will be 1, 2, 3, 4, 5. Like.
Is there any specific reason behind this?
Sagu, you try 0.5 to convert it into decimal, no? Then you will understand easily.
See, number system you think of. Is there any minus 0 in any number system?
No.
Do you think that minus 0 is there in any number system? No. So always 0 is always considered positive side only. So that's why this is your 0. Okay. So when you go to the left side, it will be incremented by 1. When you go to the right side, it will be decremented by 1. So when it is 0, the decrement means minus 1, minus 2, minus 3, like that only, no? It is so simple logic. Okay. Any number system, minus 0 and 0, there is no minus 0 in any number system. Okay. So even it is octal also, you have to write for this particular bit, you have to write that bit into 8 power minus 1. Next, plus like 8 power minus, right side you decrease, left side you increase. Next, the sum of the two unsigned binary numbers is this. So when you add two binary numbers, you got this. If one of the binary number is this, what is the value of the other number? So how will you get this suppose think that A plus B is given as a C. A plus B, sorry. A plus B value is given as C. So you know the A value, you know the A value. If you want to find out the B value, how will you calculate? B equal to C minus A. C minus A. Okay. So here you are given with the C value as well as A value. You are asked to find out the B value. Okay. So what is the C value? The C value given here is this 1, 0. This is the value given to you. Okay. So this is the C value. I am assuming it as a C. Okay. This is the A value. One of the number, I am considering that number as A. So this is the A value. Okay.
Sachindra, there is a sound from your side.
Yeah, somebody has opened your mic. You please shut down. So because here in here I have a 7 bits, and here I have a 6 bits. So that 7th bit you make it as a 0. Okay. So preceding 0 doesn't have any value. So now you subtract from C, you subtract A. So 1 minus 1 is nothing but 0. 1 minus 1 is 0. 0 minus 0 is also a 0. 1 minus 1, 0. And again 1 minus 1, 0. 1 minus 0 is 1. And 0 minus 1. So that means you cannot subtract 1 from 0. So we will get a borrow. So if it is a binary number system, how much will be borrowed? 10. Because this is a binary number system, the borrowed value will be 2 only. So 2 minus 1 will be 1.
Ma'am, can you do binary subtraction? If you subtract 0 minus 1, then
you cannot subtract 1 from 0. So
no,
what you need to do? You need to borrow.
Yeah. So
yeah, borrowed value will be in binary. The how much will be the borrowed value? It will be 2.
2 or 1, ma'am?
2, ma'am. Because how binary. See, in the decimal, how much value will borrow? Maximum 10. Why 10? Why can't it be 9?
Because it's decimal system.
Because it is a decimal number system. You will have 10 different digits. In a binary number system, you have 2 different digits. So the borrowed value will be 2. Okay.
Oh,
so 2 minus 1. Yeah.
Let's say if I want to subtract in decimal 8 minus 9, then it will be minus 1.
No, minus 1, not 18 minus 9 you do.
Ma'am, can you do 8 minus 9? Do, ma'am.
Actually, here, how you do the subtraction?
Brother, 8 minus 9 is single digit subtraction.
From 8, you cannot subtract 9. So what we'll do? We will get the borrow. So it will become 18.
Yeah.
We borrow from others now. If there is some more number, then we will be borrow. If there is only 8 minus 9.
Then how the single digit answer is coming 8 minus 9 is minus 1?
Wait, ma. Wait. 345, you need to subtract 345 from...
or double digit.
So, wait. Okay. Yeah. Suppose you tell me the answer for this. Okay. Tell me the answer for this.
92, ma'am.
Yeah. How did you got 92? How did you got the 92?
And 4 minus 5, so
You cannot do
Okay.
4 minus 5. You are borrowing. It will be 14.
Yeah.
14 minus 5, it is 9. Are you
Yeah.
writing minus 1 there?
No, ma'am.
Yeah.
Got it.
The
Why are
same
you
way.
not writing -1 then?
So the
Then,
same way
ma'am,
here also. You
then
are
the thing is, ma'am,
subtracting. Yeah.
ma'am,
Yeah.
if I want to subtract, then how the answer? If I want to subtract number 8 minus number 9, then how it is coming -1?
Yeah. In that case, you see, if you have that is not the negative side you are going. You
Yeah,
cannot.
ma'am. But ma'am, how it is justified, ma'am? Let's say any number.
This
Either
is
you
a
can
subtraction. Actually, this is a subtraction. That is a signed magnitude value. Signed magnitude value, I am not saying here. You are subtracting the addition of definitely here. You are given that addition of this will be more than that of the one of the value. Definitely, addition of the two values will be more or equal than that of the second value. So definitely the upper value is more than that of the lower value. You are getting the clue there. So you are subtracting from greater value, you are subtracting some lesser value. Definitely you will get a positive value only. Okay, you won't get negative. You can ensure that.
Ma'am, this is a signed number or unsigned number, ma'am?
Yeah, whatever it may be, you can answer like this. Say this C is nothing but addition of these two. Okay, sum of the two values will always be more or equal than the one of the values of A and B. Is it right?
Ma'am, maybe.
It can be more, or if one of the value is 0, it will be equal. It can't be less than that. So in that case, with that concept also, if you subtract this, you will get. So it is normal subtraction only, Amma. You don't think in a broad way. Okay, this is just a normal subtraction only. Okay, so binary subtraction I am doing instead of decimal subtraction. So here in this case, 1 minus 1, no problem. 0 minus 0 also no problem. 1 minus 0 also no problem. When you are subtracting 1 from 0, so you cannot do that operation. So what we'll do, we'll borrow from the previous next digit. So when you borrow, so you will get a 2 because this is a binary number system. We'll get a 2 instead of 10. So 2 minus 1 is 1. So when this gets borrowed, so you will have a 0 here. So 0 minus 0 is 0.
Ma'am, can we do the same sum by finding 2's complement of A and then adding it to C?
So another way for this is you convert this into decimal. You convert this into decimal and do the subtraction.
Ma'am, what
and
if
that result you convert again into binary.
Ma'am, what if we convert A into 2's complement of A, that is minus of A, and then add C plus minus?
Yeah, you can also do that. First you find the 2's complement of A and you add C and A.
Okay.
That will also you will get the answer. That way. Or the simple way is you convert this into decimal, you convert this into decimal, subtract the two decimal values, and the result you convert into binary.
Okay, ma'am.
Ma'am,
Okay.
if it is a signed number, then how to subtract this?
Signed number representation is see, you need to represent that value in proper way and then add it.
Yeah, that's what, ma'am. Let's say if it is a C.
Yeah, we'll get it. That also we'll get it. Wait, we'll get it. That also in the next examples we'll get it.
Okay.
So the answer we got is 0, 1, 1, 00. We'll get it. That bit also we'll get it. Wait.
First one, ma'am.
This one, 1, 1, 4 zeros. Yeah, 1, 1, 4 zeros. Okay. Next, select the decimal number for a signed magnitude binary number.
This will be minus 15.
Yeah. Signed magnitude means I told you the most significant bit is used for sign. If it is 0, it is a positive number. If it is a 1, it is a negative number. Okay. So here in this, most significant bit is 1. So that means this whole thing is a negative number and the data will be represented only from here. So this is nothing but 15 because all 4 ones means 15 and this is minus 15. Because here we have a most significant bit is 1, that means it is a negative value. So minus 15. Okay. Signed magnitude means most significant bit is used for sign, to represent the sign, whether it is a positive number or negative number. So if the most significant bit is 0, that indicate it is a positive number. If most significant bit is 1, that indicate it is a negative number. So here most significant bit is 1, so that indicates it is a negative. So minus, you have to write minus. And what is that number? To know that, you need to take only the remaining bits. In the remaining bits, sum up to 15. So the remaining bits sum up to 15. So it will be minus 15. Minus 15. Okay. See here. What is the 2's complement of the binary number? For this particular binary number, we need to find the 2's complement. So 2's complement is nothing but 1's complement plus 1. So first you write the 1's complement of this. So 1's complement is 1 1 0 0. Wherever there is 0, you put 1. Wherever there is 1, you put 0. So 1 0 1 1 0 1 1 0 0 0 1 1. 1's complement plus 1. So 1 means, how will you write 1 in 16 bits? 0 0 0 0 0 0 0 0 0 0 0 0 1. So this is 1. Okay. Now add these two. So 1 plus 1 is 2. 2 means, how will you represent 1 0? How will you represent 2? 1 0. So that means you will have
1 we will
carry
and 0 we will write.
1 will be the carry for the second bit. Here you will have the carry and here you will write the 0. Okay. Next again 1 plus 1. Again 1 0. So 0. And here you will have the carry again. Okay. So now 1 plus 0 1, 1 plus 0 again 1. So you'll have 1 here. So 0 plus 0 is 0. So the remaining bits will be as it is because we have adding with the 0 only. So I am writing 1 1 0 0 1 0 1 1 0 1 1 0. So this is the answer. The 2's complement of that is 1's complement plus 1. Okay. So this is. So the option is
second one.
0. Second one. Okay. Next. Consider the following assembly program. Assume anything after semicolon is a comment. So what we are doing here, move R1 3. So R1 contains 3 after this. R2 contains 8. Compare. CMP will do compare. That means it will subtract these two values. Jump on, it will, based on that value, it will, so you will have a 0 or negative or positive. Okay. So what it, after that, what it is saying, jump to label 1 if R1 is less than R2. The meaning of this JL less label 1 means The meaning of this is jump to label 1 if R1 is less than R2. So what is R1? 3. R2 is 8. So R1 is less than R2. So this condition is true. So after this, where we will go? We will go to the label 1. So the label 1 is here. So we will go to here. Now what we are writing here? Move R3 comma 10. So R1 is 3, R2 is 8, and R3 is 10. So what will be the final value stored in register 3? So it will be 10. Okay, because here it will move 5 to R3, but this instruction is not executed. Here, because R1 is less than R2, from this statement, it has directly jumped to this last statement. It has not executed this. So there is no chance of getting 5 in R3. So we will get a 10 in R3. So the final answer here is 10.
Ma'am, what will be the output of third instruction, third line?
It will subtract R1 and R2.
So it
Okay.
will be minus. It will be minus 5.
Yes, minus 5. But that will not affect any of the registers. That will not affect any of the registers.
What does it mean, ma'am? It will not affect me.
That means that minus 5 will not be stored in R1. R1 will be 3 only, R2 will be 8 only after this instruction also. Negative value will get here. Negative value. Negative value means R1 is less than R2. The meaning of that is less than. If you get the positive value, that indicates that R1 is greater than R2. If you get a 0, it will indicate that R1 equal to R2.
Okay.
So
And
here we are getting a negative value. So it will jump to label. Actually, here you will have a JN, jump on negative. L, not L, but like anyhow, the meaning of that is given here. This instruction, the meaning of this instruction is given here. So you consider this meaning only. Okay. So actually in processor, you will have JN, jump on negative, or JP, jump on positive.
Okay.
Okay.
And ma'am, the thing is, this is an assembly level program, right?
Yeah. This
So-
is an assembly level
So
program.
assembly level deals with decimal number or binary number.
You can consider a decimal number only. Here you consider decimal values only. Always when you are processing, you consider decimal values only. Wherever required, you convert that to binary. If
No,
your answers are like this, ones and zeros, you are
Yeah,
doing a calculation on ones and zeros, there only you consider binary. In all other places, you consider decimal only.
Yeah, I meant to say if I write this in 8051 IC, so this will be doing decimal conversion or binary conversion.
Internally, any computer processor will do binary conversions only.
Okay.
Okay,
So this
all
is a
your
assembly
computers
level, right?
will be, they will understand only binary. They can't understand decimal. But see, it looks like we are doing a decimal only, but inside, while representing, it will be represented in binary.
Okay, ma'am, this assembly language is a high level language or low level or middle level?
Low level language. Assembly language is we consider it as a low level language only, but it is an intermediate one between binary, between machine and between high level language. Assembly language will be there.
Ma'am, binary conversion, this is what, low level or high level?
Low level.
And C programming, ma'am?
High level.
Ma'am, on what basis you are saying this is a high level or low level? I mean, on what basis one should say this is a high level or low level?
Yeah, the instructions which we are writing, the statement that we are writing, C is like this: A equal to B plus C, or some scanf, printf. That is the language used, can be understood by us, but that cannot be understood by your computer. Okay, so to communicate with the computer, we are using a language which was understand by us. Using that simple statements, we are representing our idea to the computer. So there will be some translator between the computer and the user. There will be some translator. That is nothing but your compiler. Your compiler will translate the statement which you specified in C language, that it will convert into binary and then give it to the computer. Okay, then computer will compute that in the binary, that result. Again, it will give it to your converter. Your converter, that it will convert into high level language and then present to you. Okay, so you will always get your output in decimal. You are giving your input also in decimal. But to the computer, it will be presented in binary, and that whatever result it is giving is also in binary. So there will be some intermediary softwares which will convert that machine language to the high level language and high level language to the machine language. So you need not bother about them.
Got it, ma'am. Thank you.
Yeah. So consider the following assembly program. Assume after everything is semicolon is a comment. So here move instruction means 10 is stored in R1, 5 is stored in R2. Now 0 is stored in R3. Okay, so loop. Loop means these statements will be repeated. The instruction, these statements will be repeated till some condition is satisfied. Okay, so add R3 comma R2. So how much you will get? 5. When you add first time, R2 value is 5 and R3 value is 0. So you will get the result, these two gets added and the result again stored in R3. See here, it is a 2 operand only. So when you have a 2 operands for add, what it will do is both these two are added and the result again stored in this left hand side one. So R2 and R3 are added. That added value, it will update R3 with that added value. So 0 plus 5 will be 5. So after performing the first step, R3 will be 5. So decrement R1. R1 means R1 becomes 9 now. 9 now. J and Z is, so if the R1 value is not 0, again it will go and go to this loop. So these two instructions are repeated, you can say 10 times. When it will become 0, each time you are decreasing that. So 10 times this instruction gets executed. So in each time, what it is doing, it is adding R2 value to R3. Okay. So first time it is 5. Next 5 plus 5, 10. 10 plus 5, 15. 15 plus 5. Like that 10 times 50. So finally you will have in R3 you will have 50. Any doubt?
And this last statement,
No.
it is asking for R1, ma'am.
Jump back to the start of the loop if R1 is not 0. So what happened here R1? It is decrement. DEC means decrement R1 by 1. So because initially R1 contains 10, each time you decrease, how many times it needs to decrease to become 0? 10 times. So this instruction is executed 10 times. Okay. So when you add R3 to R2 10 times, what happens? Each time it is adding 5. So first time it will be 5. Next time 5 plus 5, 10. Next time 10 plus 5, 15. Next time 15 plus 5. Like that 10 times. So it will be 50. Each time it is adding 5.
Ma'am, how you directly writing 15? Is it 5 by 10? Is there any shortcut is there or what, ma'am? How, I mean, within a minute you told 50, no? So,
Yeah, 10 times. So 5 is adding 10 into 5, 50.
So let's say if it is R1 is 21 means then it will be 105.
21 into 5 to 210.
Ma'am, how this is multiplying, ma'am? I mean, how you
Not
came
multiplying, ma. Adding 5 these many number of times. That is nothing but multiplying those two. See
Okay.
here, say for example,
No,
Adding to 5 times.
I meant to say how, ma'am, you told quickly, right?
Ah,
That you
yes.
are not able to.
Yeah, see, adding the 2 5 times is nothing but 5 into 2.
Okay.
Okay,
Yes, got it.
that is equal to 10. So here also you are adding 5 10 times. Adding 5 10 times. So 10 into 5, 50.
Okay. So this a fourth statement, add R3 R3 means directly we can multiply R3 and.
No. You cannot multiply here. You are adding R3 and R2. But how many times this statement is executing, you have to see. How many times it is executing? R1 times.
Okay. Oh yeah, now got it. Thank you.
Yeah, R1 times this statement is executing. That means every time you are adding with the 5 value it is adding. That how many times that statement is executing, it depends on R1 value. So R1 times that statement is executing. So
then ma'am, this multiplication till if R3 is not 0, if it is some other value, then this will not work, right?
yeah, that will not work. Well, at the end you have to add this R3 value.
Okay, got it. Thank you.
Okay, suppose if R3 is 3. Okay, so 50 plus 3, 53 it will be. Have you got it? If R3 is initially 3, for example. So 50 plus 3 you have to do it. 53 it will be. So which of the following is responsible for managing the execution of the programs and allocating system resources? See, this is a regarding. Hello?
Ma'am, operating system.
Yeah. Compiler is the one which will convert your high level language into low level language. Okay. Debugger will also like a compiler only, but the difference between the compiler and the debugger is compiler will suppose if you have somebody switch off your mic. Yeah. Compiler, what it will do is it will compile the convert the entire program and then start executing. Suppose if your program contains 3 instructions, so it will convert all the 3 into binary. After that, it will start executing those 3 instructions. Whereas debugger, what it will do is first it will convert the first instruction, then execute immediately. Then it will convert the second instruction and execute third instruction. So line by line execution it will be done in debugger. Whereas compile means it will convert not debugger means it will find out the errors. Sorry, debugger is the one which will find out whether there are syntactic mistakes in your program or not. That will be done by your debugger. The linker is the one which will add suppose if you write a statement like hash include stdio.h or some hash include math.h libraries you will add, no? The code inside that libraries will be bring it to your program. That will be done by your linker. So the one which is allocating the system resources to you is the operating system. Okay. So actually operating system is the one which will perform mainly 4 tasks: memory management, okay, resource management, and device management, memory resource, and okay, one more thing is also. So the memory allocation and deallocation will be done by your operating system only. Resources means you'll have so many resources in your system, like your printer, memory, input output devices. All those are the resources of your system. So it will control all the devices. Whereas the device management is nothing but, suppose if you convert some external devices to your something like pen drive or something to the your system. So attaching and detaching those devices, the protocols, everything will be done by your operating system only. Okay, so those are the different functionalities of your operating system. So your operating system, allocating the system resources to the user program is done by your operating system only.
Ma'am, device manager and device management both are same.
Device management or device manager is the operating system. Device management will be done by your operating system.
No, I mean in computer we have the option for device manager, right? So if whether the device management and device manager both are same.
Yeah, almost same.
But ma'am, OS, what is the example of OS, ma'am?
Windows, Linux.
So ma'am, that device manager is something then ma'am, it is different, right?
Device management will be done by one of the component of your operating system. Like all the devices which are attached to this system will be managed by your processor, CPU. Operating system will be reside inside your CPU, central processing unit.
Okay, ma'am, debugger will check for syntax error?
Yes. It will check for the syntax errors.
And compiler will not check?
Compiler will convert binary machine high-level language into machine language. While converting, it will make use of the debugger.
I mean to say all compiler are debugger?
Every compiler will have a debugger, definitely.
No, I mean to say compiler is a debugger?
No. Compiler is not a debugger. One of the part of the compiler is a debugger.
Ma'am, Turbo C is what, ma'am, compiler or debugger?
Turbo C is an editor. Turbo C is an editor which will provide a user environment for compiling your C program.
Ma'am, to compile a C program, we write a program in a compiler, Turbo C, right? We install
Turbo C is an editor. Turbo C is an editor where you can edit your C program and compile it and run it. It will help you. It will provide an environment, something like your notepad. It is something like your notepad only, where you will type your program, but it has additional facilities to compile that in C language and execute it.
So, Turbo C is not a compiler?
No, it is an editor.
Okay, ma'am. Thank you.
Which contains compiler and execute. It will even provide the environment to compile your C program, to edit your C program. Editor only. Turbo C is an editor. Okay. So, which component of your computer system is responsible for directing the booting process? BIOS. So, when you start your computer, BIOS, inside the BIOS, you will have instructions what you need to do. Okay. So, the main component which will be helpful for booting your system is a BIOS. Whereas ALU is used for performing arithmetic operations. RAM is the random access memory. When you are executing your program, it is loaded into RAM. And your hard disk is a secondary storage device. Okay. So, BIOS is the one which will help you to boot your system.
Ma'am, what is the basic meaning of booting, ma'am? What do you mean by when you say your computer? It is a very common term. People used to say computer is booting or not booting. What does it mean, ma'am?
It will come to the state where your operating system can provide the services to the user.
Ma'am, booting and restart both are same or reset?
So when you start your system, restart or whatever it be, start the system, the first component, that first software that run in your system is the BIOS.
Ma'am, BIOS will wake up the operating system, right?
Yeah, it will build up the it will bring the operating system into RAM.
Yes.
Operating system into RAM. Okay.
Yeah, anything which is in the RAM, then only it can able to run continuously. So it will bring the operating system into the RAM BIOS, so that your operating system will be running and it will control all your devices. As long as your system is on, your operating system is in the RAM, and it will control all the devices, all the programs that are running.
So, ma'am, all system will have irrespective of whether it is a desktop, computer, or mobile, all have a BIOS.
No, your desktop, mobile, or mouse, everything are hardware components. Your operating system is a software which will control all these devices. Okay, operating system is the one which will control all these hardware devices. A program, software program. Operating system is a software program. Okay, it will control all the devices that are connected to it, because it will reside when your system is on, when your operating system comes to the active state, it will be in the main memory, RAM. It will be in the RAM. Okay, it is in the executable mode. Your operating system is in the executable mode.
Ma'am, it means our mobile phone also have BIOS, no?
Yeah, your mobile phone will also have operating system.
No, ma'am, BIOS.
Yes, BIOS. When you reboot it, your BIOS will bring your iOS into the RAM.
Ma'am, microprocessor also have a BIOS like 8085.
Maybe, I think every electronic device which operates on software will have a BIOS.
But ma'am, you told that it will convert operating system into RAM, right? But the
It will
basic
bring your operating system into RAM.
operating system into RAM. But ma'am,
Operating
basic
system is a program. You can say operating system is a program. So your program will able to execute or the control the other parts only when it is in main memory. So your main memory is nothing but RAM. So your BIOS will bring your operating system into RAM.
Okay, ma'am.
So that your operating system will be in the executable mode. So it will able to control all the devices that are connected to the CPU.
But ma'am, I meant to say, ma'am, basic microprocessor doesn't have register, right? RAM is register, right?
RAM is a memory, main memory, you can say, volatile memory.
Yeah, but ma'am, basic microprocessor doesn't have this RAM, no?
Maybe I think inside some chip, chips will be there. In that RAM chips, your software might be running.
But ma'am, it is saying that basic 4-bit microprocessor doesn't have any register, any memory. So
might be ma. All these are see your operating system is a software. Anyhow, your computer will have input, processor, output. No, that processor is a RAM. Like your processor. One of the component of your processor in the memory, you can have your operating system. Operating system is a software. Your processor is a hardware. Okay, your processor is a hardware. Operating system is a software which will control that hardware. Operating system is a program. Okay, so according to the program, what it is saying, your devices, your hardware devices will run accordingly.
Ma'am, I did not get this point.
Suppose you have written a program to do something. You are reading some number from the keyboard. and you want to add those two values. You are reading two numbers from the keyboard. You want to add those two values, and then that result you want to display on your monitor. Okay. So for performing that, you will write a code. You will write a code. So the code which was written by you is a software. So according to the software, what it is saying, so first instruction is you are reading two values from the keyboard. So first it has to contact your hardware device keyboard, retrieve those two values, get into the memory, some register processor memory, then it will add those two. That result again it will store in a processor memory, and that memory it will contact your output device monitor, and then write that to your monitor. So that means your program is a software. Okay, so it will have the instructions what each component of your system has to do. So your CPU will retrieve the first instruction and send it to the keyboard, and your keyboard will interrupt. It will send the value, required value. Again, that value your CPU will store it in one of the register. Again, it will read the second value from the keyboard, that it will store it in the one of the registers. So that everything will be done by your processor. Your processor is controlled according to the program which we have written. That is a software. So how your processor will run is according to your operating system. What your operating system will say, according to that your processor will work. So processor is a hardware, whereas your operating system is a software which will give the instructions to all the devices. You give some value, you display this value. That instructions in the understandable form of your device it will send. I think you are overthinking about the functionality.
Just for the curiosity, how these things are working. So
Okay.
this BIOS is not a hardware.
BIOS is not a hardware. It is also a program which will bring your. There will be some, I think, internal chips, RAM chips, or PROM or something is there inside. So from that, it will bring the operating system program into the RAM. That is also a software. BIOS is also a software.
And this ALU, RAM, HDD, these are not software.
ALU is one of the component in your CPU.
Yeah, that's
arithmetic logic unit.
So ALU, RAM, and HDD, these three are hardware, and BIOS is not a hardware.
Not a hardware. It is a software, a program. BIOS is also a program which will bring your operating system into the main memory.
It will bring operating system into memory. Okay.
So, which of the following is machine independent? Actually, assembly language. See, machine language is a which machine dependent only. Okay. Assembly language is not machine like machine dependent. Assembly language is a machine dependent because 8086 the assembly language is different. 8088 the assembly language is different. So this is a machine dependent language. This is a machine dependent.
Assembly language is of 2 bits only, no 0 1.
Machine language is a machine independent. Like any machine will accept only ones and zeros. Okay. High level language is also okay. Assembly language is machine dependent, definitely, because I think machine language is also a machine dependent because the mnemonics or the codes which is used by 8086 is different, 8088 is different. Like I think high level language is machine independent.
Ma'am, what is machine language?
Machine language. See here, machine language is something, a code in the form of ones and zeros. Okay. Say, for example, if you say add, suppose if you say add, okay. So the add code is different for 8086. It can be say 1010 in 8086. Maybe it can be a 11 in 8088. Okay. So it depends, like the code will vary based on the processor.
So this
Okay.
add is an assembly language, right?
Yeah, this add is an assembly language, and even some of the processor it will be add. In some of the process it will be only A. Okay, that code will vary. This mnemonic will vary based on the machine processor. 8086 you'll have a different mnemonic. 8088 you will have a different mnemonic, and the encoded value will also be different for different processors. So only the language which is machine independent is a high level language.
Madam, if you have completed
Yeah.
Okay. No, question number 3, can you explain once again, madam, how that 8 has come?
3.
Yeah, this
Yeah.
8.
See here we have asked the negative range. Negative range.
Yes, ma'am.
So total you have a 32 bits. You can say like this. Total you have a 32 bits. Like this. Okay. So negative means most significant bit. This 32 bit will be 1.
Yes, ma'am.
Okay. So this will be 1. All the bits can be, all the 32 bits can be 0 or 1, and all the 32 bits can be ones.
Okay.
Okay. So when all the 32 bits are ones, you will get F like that.
Okay.
When you get this data is 0, then this will be this last this can be
4
8.
significant. 4 significant bits will be 1000.
0. So
that
it will be 8.
8. Okay. Thank you, ma'am.
Okay. So that's why it is from 8000000 to 0x all Fs.
The 0x, ma'am?
Yeah. 0x is hexadecimal. Each bit is represented using 4 bits. Each digit is represented using 4 bits. 8 4s are 32. So this is a 32 bit.
Okay.
Hexadecimal.
Thank you very much, ma'am.
Okay, let us check whether the answers given by us are correct or not. Yeah, all are correct. Okay, any doubts?